Today we are going to tackle the fourth and final part of our introduction to finding limits algebraically, and that is how to handle piecewise functions. Just to do a quick recap, if you want to jot this down, our steps for finding limits from just the equations. The first thing you should always try, so step number one is going to be to plug in the value that your x is approaching. So in the scenario, we try to plug in 4 and see if you just get a numerical answer out. If you don't, if you end up with an undefined answer that makes your universe explode, the next step I always recommend doing is to factor and cancel the terms that are causing problems. And if you can't do that, so if you can't factor and cancel the terms that are causing problems, and you end up with a number over 0, the last thing that you'll have to be able to do when you can't factor and you can't plug in is you have to check and see whether your limit is infinity, negative infinity, or DNE. And to do that, we basically tested your left-hand limits and your right-hand limits. So you had to plug in things that were very close to the number you were approaching from the left-hand side and from the right-hand side and see if they matched in sign or didn't. And then you could give me one of these very precise answers for the limit of that equation. Now we're going to solve piecewise functions in a similar fashion to what we did here. So we are going to be testing the left-hand and right-hand limits because, as you can see, this function, for example, is broken up into two pieces that are greater than 4 and pieces that are less than 4. And so we'll have to do our left and right-hand limit. But for piecewise functions, you could get actual numerical answers. So like up here, we had our only options were infinity, negative infinity, or DNE. That's not true for piecewise functions. So I just want to make that distinction right off the bat. All right, so let's go ahead and we're going to start with this example. So we're finding the limit of f of x as x approaches 4. And so I'm going to find my left-hand limit and my right-hand limit separately. So here's my left-hand limit, and this is for values less than 4 would be what I test in here. And so if I'm looking at my piecewise function, the part of your equation that applies to values, x values less than 4, is this bottom piece. And so that's the piece I'm finding the limit of. And so when I find the limit, the first thing you're going to try of this piece is just try and plug in 4, which works because we end up getting 0, and 0 is a perfectly good number. So that's our left-hand limit. For our right-hand limit, I'm going to go ahead and use the other part of my piecewise function. So up here, because this equation is for x values greater than 4, and that's what the right-hand limit applies to. So again, I'm just going to go ahead and plug in first, see if that works. Well, 4 minus 4 is 0. Square root of 0 is in fact 0. Perfectly good number. And so now, because I did my left-hand limit and my right-hand limit, I can find my general limit. So the limit of f of x as x approaches 4. And because these match and are both defined, our general limit is also 0. All right, we're going to try another example kind of just like that one, but with different equations. So in this one, I want to find the limit of g of y as x approaches negative 2. And that's the breaking point of this piecewise function. So I'm going to do my left-hand limit first. So limit of g of y as x approaches negative 2 from the left-hand side. And that would be for values less than negative 2. So like negative 3, negative 4, negative 5. And so that's the top equation. It's okay if they're not in the same order as in the previous example. And so then when I go ahead and I plug in negative 2 there, because that's the first thing you always try when you're evaluating the limit, negative 2 squared is 4, 4 plus 5 is 9. And then I'll go ahead and try my right-hand limit. So the limit of g of y as x approaches negative 2 from the right-hand side. That's going to apply to now this bottom part of this equation because this is for values greater than negative 2. So for negative 1, 0, 10, those all work in this scenario. And I'm going to go ahead and plug in negative 2. Negative 3 times negative 2 is a positive 6, and 1 plus 6 is 7. So then now we have my left-hand limit and my right-hand limit, and they don't match. So I would say the limit of g of y as x approaches negative 2, although I guess this should be a y here. Go ahead and make that switch on your paper. Does not exist because your left-hand limit and your right-hand limit are not the same. All right, last example. We are going to go through, and this one wants me to find two different limits, two different general limits, and that's because I have so many breaking points on this piecewise function, right? Between the top two equations, those change over at -2, and then my bottom two equations change over at +2, and so I have to double check and see whether or not my function has the same limit there for both the top and middle equations, and then the middle and bottom equations. So let's tackle the left-hand limit of g of x as x approaches -2. So there's my left-hand limit. And so I'm looking for the equation that uses values less than -2, so values to the left of -2, and so that would be this top equation right here. And so then let's see, I would just plug in I have a negative already there, and then I plug in my -2, so my answer is +2. And then my right-hand limit for g of x as x approaches -2, there's my right-hand limit, means I'm going to pick the equation that is greater than -2, but be careful. You only want to pick, when we're finding the limit, we're getting very, very close to -2, but just slightly greater than that. So you still want to use this middle equation because this is for values that are greater than -2, but less than 2. So these are going to be the values that are close to -2 and just slightly bigger than it. So this is what you use for your right-hand limit for this first general limit. So I'm going to go ahead and I have 1/2 -2 squared minus 1, which gives me -2 squared is 4. 4 times 1/2 is 2. 2 minus 1 is 1. Okay, so then right off the bat, I can see that my general limit for -2, because my left and right hands aren't the same, would be D and E, because your left-hand limit does not equal your right-hand limit. And now I can go ahead and I can do the same thing for my second general limit it wants me to find. So now we're working with this one. So now I'm looking at my limit of g of x as x approaches 2, just +2 now from the left-hand side. And so I'm looking for values that are slightly less than 2, but very close to 2. So I'm going to use my middle equation first for that piece, because these are the values that are less than 2, but greater than -2. So these are going to be the ones that are close to 2. So 1/2 2 squared minus 1, which will give me 2 squared is 4. 4 times 1/2 is 2. 2 minus 1 is 1. And then for my right-hand limit, I'm going to be testing things that are very close to 2 but slightly greater than 2. So that would be this bottom equation. Oops, not negative anymore. So I'm plugging in just a 2 there. That negative's already out front. +3. So -2 plus 3 is 1. And so then overall, because my left-hand limit and my right-hand limit match for just +2, I know that this general limit right here is 1. There you go. All right, so that's the end of our introduction to finding limits algebraically. We are going to move on to some more advanced algebraic manipulation, but please just first and foremost let me know if you have any questions on piecewise functions or anything else that was in this packet.